Okay, and welcome to my next video on implementation of stacks using arrays. Let's start now. So basically here we would like to implement stacks using arrays, or stack using arrays. Okay, so basically what is an array? Array is a collection of homogeneous elements, right? Array is a collection of homogeneous elements of fixed size. For example, you take this array here. We have taken this array as stack. The name of the array is stack. We have 0, 1, 2, 3, 4 elements. So basically here, as you can see, the size of the array is 5. Therefore, here in this example, I would like to name the array as stack, which has a maximum of 5 elements: 0, 1, 2, 3 and 4. So that is the reason here we have defined max as 5. The maximum number of elements is 5. So here int stack of 5, where 5 is the size of the array initially. Therefore array is represented like this, but we can also represent array in this manner as a stack as well. So this and this are both the same. So basically here we index 0, index 1, index 2, index 3 and index 4. This is a stack. This is a stack, and the name of the array here is nothing but a stack. Therefore here initially the size of the array is 5 and top is pointed to -1, which means that we have an empty stack where no element has yet been inserted. If the top was pointing towards 0, it means that an element has been inserted at the 0th position. But now, because top is pointing towards -1, it means that the stack is empty. That is what we need to know. Therefore, therefore 2 points. Basically here we have a stack. Stack is nothing but an array where I have maximum size of 5 elements. The size of an array is 5. So let us start with execution of our program from the main function. As we all know, execution of the program starts from the main function. Therefore, as we go directly down to the main function, you have something called push of 10. Push is a simple function and we pass 10 as a parameter. So the control goes from this line to the push function, right? Therefore the control goes towards the push function here, right? The control comes here and now 10 is passed to this value. Now it comes to the next line and it checks whether if E is full, whether the stack is full or not. So this again is basically a function call. So we go to the top now and the control comes to this point where it says E is full. Basically this function returns an integer type, and you can see this return top equal to -1. We know that top equal to -1 and top equal to max -1. What is max -1? Max is 5. 5 minus 1 is 4. Therefore is -1 equal to 4? The answer is basically false, right? The answer is false. Therefore whenever we have false, it returns 0. It returns 0. Therefore where does it return? It returns to the place which has been called, right? Which was called basically, right? Therefore it returns to this position. Therefore if 0, if false, therefore it does not go into the if statement, it goes directly to the else statement, right? Inside the else we increment the top, right? Increment the top. Therefore top was -1, top becomes now 0. So basically top plus means top is equal to top plus 1. Therefore top was -1. Now top will become -1 plus 1, that is 0. Now top is 0, which means that top will now point towards the 0th position, right? Top will now points towards the 0th position. Top is equal to 0. Top is equal to 0, which means that top will now point towards the 0th position. Now we are ready to insert element into the 0th position. One important thing is that we first need to point top to a particular position and then insert the element in that position, and not the vice versa, right? So now here top has become 0 here, and then we say stack of top, that is stack of 0 equal to value. The value was 10, therefore assignment from right hand side to left hand side, therefore stack of 0 would be 10, therefore here 10 would be inserted. And then after inserting, we say percentile d is nothing but value 10 pushed into the stack, that would be printed. Then we finish out the push function. Therefore after finishing the execution of the push function, we go back again to the main function, right? Main function. Now we have again what? Push 20. Again the push function is called, basically, right? We call this push function where you now have value as 20, and again we say if is full, right? If is full, therefore again the is full function is called. Let's go to the is full function, and now you have top as 0. Again it will check now whether 0 is equal to max minus 1, that is 4. Is 0 equal to 4? False. Therefore it returns 0. Where does it return? It returns to the place which was called, right? Basically here it returns 0 here, right? If false, then it comes to the else statement, and it says again top plus plus, which means that top was 0, now top would be 0 plus 1, that is 1. And then we say stack of top, that is stack of 1 equal to 20, where 20 would be inserted into stack of 1. As you can see here, we go to this place and insert 20. In this way, push operation works, correct? Right now, therefore, suppose in the same way, if I insert 30, 90, 100, as you can see, once I insert that, the top will point towards the 4th position, right? Top will point towards the 4th position. So I will say here 0, and then I will say here top will point towards the 4th position, right? Now I want to insert, and suppose I want to insert an other element. So what would happen, right? So now here the push function will be called. It will check if is full. The is full function would be called, and now we check whether top is equal to max minus 1. What is top here? 4. Is 4 equal to 4? True. Therefore it will return 1. Where will it return? To this place. If 1, instead of is full we have if 1. If 1 means if true. Yes, it is true. Therefore it will say stack overflow cannot insert. What is percentile d, guys? I suppose I want to insert 120. It will say stack overflow cannot insert 120. The value is 120, right? Therefore we have seen the overflow condition as well. Right now, after inserting these elements, suppose if I want to pop out the element. Right now, if I want to pop out the element, 100 would be popped out, right? Because it is a LIFO. Stack is a LIFO data structure where LIFO means last in, first out. The element that has been inserted last would be popped out first, right? Element that has been inserted last would be popped out first. Last in, first out, right? Therefore, let us see the pop function. How does that work right now, right? So now you have your pop function. Suppose a pop function is called from the main function. As you can see here, from the main function, suppose I call the pop function here, right? So I have not written any pop function here. I can just here after basically pushing all the elements, I can just write a simple pop function here. That's it, pop function, right? So we push 10, 20, 30, and after 30, if I can see the stack now, after 30 we have 90 and 100. Therefore in the main function, I will say here it would be push 90 and push 100, and after that, after this is the first push function, this is the second, this is the third, this is the fourth, and this is the fifth. After pushing all the 5 elements into the stack, suppose if I call the pop function, what would happen, right? What would happen? Now let us go to the pop function. So here we check first whether the stack is empty or not. So the reason for checking whether the stack is empty or not is that you want to check whether there are any elements in it or not. Only if there are elements you want to pop the element. Otherwise you say, the stack is empty, cannot pop any more elements, right? So let us go to the isEmpty function. So if isEmpty is a function, so let us jump directly to isEmpty, right? IsEmpty, and it returns what? Top equal to 1. This is equal to 1. So basically it returns a boolean value. Is top equal to 1? No, top is basically 4. So what would happen? It will return false. Means it will return 0. Where will it return? It will return to this particular position. If 0, if false, then what would happen? Basically it will go to the else statement, and inside this else statement it is something like int val equal to stack of top, which means that stack of 4. The right now stack is the top is pointing towards the 4th element. As you can see here, top is pointing towards the 4th element. Therefore it will basically return what? It will return 100, right? It will return 100. As you can see here, 100 was there, therefore it would return stack of the value of stack of 4 is nothing but 100, therefore it will return 100, and value will now contain 100. And now I am saying top minus minus, which means that basically top was 4, now top would become 3, right? Let us change the pointer here right now. So basically here, okay, so I will just delete this here, and I will say here, I will write 4 here, and now top would be pointing towards 3, which means that top would be pointing towards the element 90, right? So let us go down now here. Now what would happen? Once the top is pointing towards 3, this element is automatically garbage collected. We have moved top from 4 to 3. And one important point is that before moving from 4 to 3, I just stored the value of stack of 4 into a variable called val. Why? Because once the element is garbage collected, I cannot retrieve that value. I cannot display that value to the user. That is the reason, for display purposes, I just stored the value of stack of 4 into a particular variable called value. That's it, right? That's it. So basically, and then I said top minus minus, which means that whenever I say top minus minus, what is going to happen? The top will move from actually moved from 4 to 3. Top is now pointing towards 3, and the element inside index 4 is garbage collected, that is 100 is garbage collected, and now top is pointing towards 3. Right? No, basically what do I mean by garbage collected? It means that this element 100 is popped out of the stack, right? And I say return, and I say basically return val. Where will it return? It will return to the place with function which called it, right? Therefore here, instead of push, I can say, I'll just delete this pop. So instead of pop, I can say here int, right? After 5, after all the push functions, I say int val equal to pop. So basically value 100 will now be stored in val, right? Will now be stored in val. Okay, I hope you understood the pop statement. It is very, very simple. Basically, I'll just draw it quickly here. Now suppose you insert 10, you have inserted 20, you have inserted 30, you have inserted 90, and you have inserted 100, and then top was pointing towards 100. So basically what did we do? We just stored 100 inside a particular variable called val, and then I said top minus minus. Once I said top minus minus, what happens? The top will now point towards this third element, 0 1 2. Top will now point towards this third element, and once top is pointing towards the third element, it is no longer pointing towards the fourth element. Therefore this is garbage collected, which means that 100 has been popped out. Right now, again, if I want to pop out 90, what will happen? What will I do? Basically, I will just decrement top. I'll say top minus minus. Therefore top now will become basically what? Top will now point towards the index 2, and 90 would be garbage collected, which means that 90 would be popped out. Right, again I will do the same thing. I will just call the pop function again. When I call the pop function again, I decrement top minus, I decrement top, I say top minus minus. Therefore top will now point towards 1, right, and then 30 would be garbage collected. Similarly, the same thing again, if I call top minus minus, the same thing happens. Basically top will move from 1 to 0, right, 1 to 0, and 20 would be garbage collected. Now again, if there is a single element, right, single element, I say here what? Top minus minus again, right, and then top would become minus 1, and then this would be garbage collected. And then once top becomes minus 1, the stack is empty. So basically, again, if now when top equal to minus 1, again if you try to remove any element from the stack, then what happens? The isEmpty function is called, right? The isEmpty function is called here. isEmpty function is called. You go to the isEmpty function, where now return top equal to minus 1. So basically top became minus 1, equal to minus 1 is true. Therefore it will return here basically 1, right? 1. If true, then I'll print stack underflow. Stack underflow cannot pop any more elements. Therefore here this became 1, and it will print out stack underflow cannot pop any more elements. Therefore we have seen two functions. One function is the push function, where you pass an element. Another function is the pop function, where you just pop out the last inserted element. Push and pop take place from just one end, right? How do you pop out? You just move the top pointer down, and then automatically the element before that will be popped out. Correct? Now we go to another function called display. So suppose before popping out all the elements, you have some elements in this stack, right? Something like, again we'll draw those elements: 10, 20, 30, 90 and 100, 0, 1, 2, 3 and 4. If you want to display all these elements, how do you display? Very simple. You just call the isEmpty function. We know, right? isEmpty matlab if top equal to minus 1. Top is 4, right? Top is 4 here. Top is not equal to minus 1. Therefore it comes to the else statement. We print out the stack elements are basically I equal to 0, right? I is less than equal to top. Therefore 0, we need to check whether 0 is less than equal to top. What is top? 4. 0 is less than 4 is absolutely true. Therefore it comes inside the for loop. It will print stack of 0, matlab it will print out 10. After printing out 10, I plus plus happens. I will become 1. It will check whether 1 is less than 4. Yes, it comes inside stack of 1, that is 20. Now I plus plus, I becomes 2. 2 is less than 4, true. It comes inside, prints out 30, right? After printing out 30, I is incremented. I becomes 3. 3 is less than 4 is absolutely true. Therefore it comes inside stack of 3, that is 90 would be displayed. Now I would be incremented. I will become 4. 4 is less than or equal to 4. Yes, 4 is equal to 4 is true. It comes inside, prints out 100. Now again, I plus plus, I becomes 5. 5 is 5 less than or equal to 4? False. Therefore, it comes out of the for loop and then printf slash n, which means that it goes to the next line basically, right? Therefore, these elements are being displayed, correct? And now if we call the peak function, right? We also have a function called the peak function. Peak function does not take any parameters. We just call the peak function. Suppose I have after all this, I have called the peak function here. Peak function basically displays the top of the stack. So basically, once I call the peak function here, I will check whether the stack is empty or not. So if I have elements here, suppose I have this stack here where I have all these elements, right? The stack is not empty because we know the empty condition. Whether we will need to check whether top is equal to -1. Top is basically here 4, therefore this is false. Therefore it goes to basically the else statement, and it returns stack of top, right? Top is pointing towards 4, therefore it will return basically stack of 4, that is nothing but 100. That is nothing but 100. Therefore, in the peak function, when we write the peak function, we also need to use a return value. Therefore, I need to say int value is equal to peak. As you can see here, peak returns an integer value. Therefore, while calling that function, we need to write int value equal to peak. Therefore, in place of peak, 100 will be returned and value equal to 100. Therefore, 100 will be stored in a value, right? So basically, in this video, we have seen the push operation where we passed values. Suppose I passed 90. We have also seen the pop operation where we have pop dot values. We have seen the peak operation where we directly try to get the top of the stack. We have seen the is empty condition where we say top equal to -1, and then if this is true, then we say underflow condition, which means that we cannot pop out any more elements. If full, right? If full, this condition says that if top equal to max -1, top equal to max -1. If this condition is true, then we cannot insert any more elements. Therefore, these are all the 5 operations that we have seen on stack today, and I hope you have understood all the operations, right? In the next video, I am going to talk about applications of stack, like conversion of infix to prefix, infix to postfix, prefix to infix, postfix to infix, etc., etc. Thank you for watching this video.